Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually teaching the exercise questions of the chapter 7 of 9th standard science subject. That was on motion. Coming to the 7th question, here a ball is actually gently dropped onto the ground. So let's assume this as ball and this as ground, and this particular ball has gently dropped on this particular ground. So here this particular ball will acquire 10 meter per second square acceleration while traveling towards the ground, and you have to calculate the final velocity of this particular ball just before it strikes that particular ground. So the height from which this particular ball is being dropped is 20 meter, and they have given acceleration of this particular ball. Now you have to calculate the final velocity at which this particular ball will be striking the ground. So now here you can see initially the ball was there at a particular height. So that means we have to assume that it was at rest, and we have to consider initial velocity as 0. Now we have to calculate the final velocity. In order to calculate final velocity, what is the distance? Distance we can take it as s. So s will be equal to 20 meter, and they have given acceleration also. So acceleration is 10 meter per second square. So everything is in SI units. So directly you can substitute these values in the equations of motion to calculate the final velocity. So if you consider the first equation, here you have v is equal to u plus at. So now based on this particular data, what is u? U is 0. Plus what is acceleration? Acceleration is 10, and we don't know what is the time. So this you can call this as equation 1. Now in order to calculate time, we can consider the second equation of motion, that is distance s is equal to ut plus half at square. Now again you can see here we don't know what is the time, but we know what is the distance and we know what is the initial velocity. So what is initial velocity? Initial velocity is 0. So this value becomes 0 and this entire value will be 0. Now s is equal to half at square is there. So now let us keep t square in RHS itself. We can bring this a by 2 to LHS. So it will become 2 by a. So s into 2 by a will be equal to t square. Now we have got t square is equal to s into 2 by a. So what is s? S is distance, that is 20 meter into 2 divided by what is acceleration? Acceleration is 10 meter per second square. So 0 0 gets cancelled with each other. 2 2s are 4. So now we have got t square as 4 second square. Now in order to get the time, we can take square root on both sides. So taking square root on both sides, you will get the time. So when you take square root on both sides, here t square will be there. Square root of t square will be there. On RHS also square root of 4 second square will be there. So always remember, when you take square root, the values will be in plus or minus. Because always you should remember, when you do plus 2 square, the answer will be 4. So when you do minus 2 square, then also answer will be 4, because minus 2 square is minus 2 into minus 2. When you do minus 2 into minus 2, it will become plus 4, because minus into minus is plus. So that's why whenever you take square root of 4, the value will be either plus or minus 2. But in this particular case, you should just consider plus 2, because time cannot be negative. So only positive value can be there for time. So in this particular case, you can just take the positive value of plus or minus 2. So that's why here I am erasing this particular minus. So now plus square root of 4 second square is there. So when you take square root of t square, it will be t. When you take square root of 4 second square, it will be 2 second. Because here second square is there. When you take square root, it will become second. When you take square root of 4, it will become 2. So that means here you have got time as 2 seconds. Now coming back to the equation 1. So what is the equation 1 which we have got? The equation 1 is v is equal to 10t. So v is equal to 10t is the equation 1. So in this particular t, you can substitute this t is equal to 2 second value. So here we have got t is equal to 2 second value. So v is equal to 10 into 2. So what is the final velocity we are getting? Final velocity as 20. Everything we have calculated in SI units. So 20 meter per second is the answer for the final velocity of this particular ball. That is, at 20 meter per second square velocity, it will be hitting the ground. So that means while that particular ball is hitting the ground, it will be having almost 20 meter per second velocity. And the extended question which they have asked in this particular same 7th question is to calculate the total time. That is t. So we have already calculated time before calculating the velocity itself. So that particular time is 2 seconds. So the final velocity of the ball is 20 meter per second while it is about to hit the ground, and the time taken for that particular ball to reach that point from the 20 meter height is 2 seconds. So coming to the 8th question, here they have given graph and they have asked 2 questions. So coming to the first question, here a particular car is actually traveling. So here, if I draw this particular graph, they have actually given speed versus time graph, where speed is taken on y-axis and time is taken on x-axis, and a particular car is traveling. So here you should actually calculate the distance traveled by car at 4 seconds. So now, if you just look at the graph and get the speed, that means if you let's say here 4 seconds is there. So here if you draw a perpendicular line from 4 seconds to the graph, you will reach a particular point, and from this particular point you should draw a perpendicular line to y-axis, and whatever the value you are getting here will be the speed of this particular car at 4 second time. It will be equal to 6 meter per second. So here you can look at the graph and you can only locate that at 6 meter per second speed the time is 4 seconds. So this speed, you can consider this as the final velocity, and time they have given, and you can consider initial velocity as 0. So we'll move on to the first equation of motion, that is v is equal to u plus at. So here initial velocity is 0, here also initial velocity is 0. So here v will be equal to at and acceleration will be equal to v by t. So what is v? V is the final velocity. So here acceleration is, final velocity is 6 meter per second, which we have observed from the graph, divided by time. Time is 4 seconds. So 2 2s are 4, 2 3s are 6. So 3 by 2 is there, 3 by 2 is 1.5. So 1.5 meter per second square is the acceleration. So now you can calculate the distance. So distance is half at square. Since initial velocity is 0, that ut will be equal to 0. So only the remaining thing you can write here, that is half at square. So s is equal to, that is the distance. This s is actually the distance. S is equal to half. What is acceleration? Acceleration is 1.5 into what is the time? Time is 4 seconds. So 4 into 4. So here 2 2s are 4, 2 1s are 2. So 4 2s are 8 is there. So 1.5 into 8 will be there. So 0.5 into 8 is 4. 4 plus 8 will be 12. So 12 meter is the total distance traveled by this particular car in first 4 seconds. The second part in the same A question, in 8th question, they have asked to shade the distance which traveled by this particular car. So always remember, in a velocity versus time graph or in the speed versus time graph, area under the curve will give you the total distance traveled by that particular car. So here we have to just shade this initial part. So this particular part you can actually shade. So this initial part will give you the total distance, because here they have just asked till 4 seconds. So only you can draw a perpendicular line from 4 seconds to graph and you can share this particular initial part. So this is the answer for the second part of A question. So coming to the B question in the same 8th question, here they have asked which part of the graph represents uniform motion of the car. So here if you carefully observe, after 6 seconds, speed has become constant. So after 6 seconds, you can observe there is a parallel line for this particular x-axis. That means here speed has become constant after 6 second time. So here the graph which is there after 6 second represents the uniform speed of this particular car. So this is the answer for B question. Coming to the 9th question, here they have given 3 different statements. You should actually tell with an example whether that particular situation is possible or not possible. So coming to the first statement here, in the 9th question, there they have given an object with a constant acceleration but with zero velocity. Here if you are considering a ball, and if you are throwing that ball vertically upwards from the ground, so the highest position at which this particular ball reaches will have velocity equal to 0, because the final point at which this particular ball reaches, at that particular position the velocity will be 0. Again, due to the acceleration, it will come down to the earth. So because earth has a certain amount of gravitation, so because of that, acceleration due to gravity will be acting upon that particular ball. That means at the highest position, this particular ball will be having velocity equal to 0 and acceleration equal to 9.8 meter per second square. At that particular highest position, for few milliseconds or microseconds, that particular ball will be at rest. That means its velocity will be 0. And again, due to acceleration due to gravity, it will be falling back towards the earth. So now coming to the B question, here they have asked an object moving with an acceleration but with uniform speed. So that means here there is acceleration and there is uniform speed as well. So this is actually contradicting, because when a particular object has uniform speed, there will be zero acceleration. But if you consider circular motion, so now if you consider circular motion, there is a circular path like this and an object is traveling on this particular circular path with uniform speed. That means here object has uniform speed, but every instant on that particular circular path, this particular object is changing its direction. Because there is continuous change in direction for this object, this particular object is said to be an accelerated motioned object. That means the motion of this particular object is considered as the accelerated motion. That means this particular motion is an accelerated motion but traveling at uniform speed. So here the motion is accelerated. So here the motion of this particular object is accelerated motion and it can travel at uniform speed as well on this particular circular path. So this particular exceptional example will give you an idea that the motion is accelerated motion, at the same time object will be traveling at uniform speed and it is remaining on that particular circular path. Coming to the C question in this particular 9th question, here they have asked an object moving in a certain direction with an acceleration in the perpendicular direction. So now here you can consider two different acceleration. A particular object is moving on a particular road. So now if this particular object has certain acceleration, that means this acceleration is in this particular direction. Now acceleration due to gravity is also applied on this particular object, because this particular object which is moving on the road, that means it is actually moving on the earth's surface. So that means here there will be acceleration due to gravity as well. So that means acceleration due to gravity is also applied on this particular object, and this particular object is accelerating in horizontal direction as well. So that means this particular horizontal acceleration is with perpendicular to the acceleration due to gravity, because the direction of acceleration of this particular object is in horizontal direction and the direction of acceleration due to gravity is in vertical direction. So that means here both are perpendicular to each other. So this particular situation you can give as an example for this particular C question in 9th question. So coming to the 10th question, here there is an artificial satellite which is actually revolving around a particular planet. So now you have to calculate the speed of this particular artificial satellite which is revolving around this particular planet. So the data which they have given here is the radius of this particular circular path in which this satellite is revolving is equal to, so the radius is equal to 42,250 kilometer, and they have also given time to complete one complete revolution around that planet. It is taking 24 hours time per revolution. So that means to make one particular revolution it is taking 24 hours. That is, this particular satellite is taking 24 hours to complete one revolution. So now, based upon this particular data, you have to calculate the velocity or the speed of this particular satellite. So now, what is the formula to calculate velocity? Simply we can put total distance divided by total time. So what is the total distance? So here they have given time for one revolution. That means it has covered one complete revolution. That means entire circumference of that particular circular path can be considered as the total distance. And what is the formula for circumference? The formula for circumference is 2 pi r and total time taken is 24 hours. So now 2 into 22 by 7 into 42,250 kilometer divided by 24 hours is there. So I'll write this in a new slide. So velocity V is equal to 2 into 22 by 7 into 42,250 kilometer divided by 24 hours. Now you can calculate this. So when you calculate this, you will get 11,065 kilometer per hour as your velocity of this particular satellite. So now if you want to convert this hour into seconds, then you can divide this with 3,600. So 11,065 kilometer, when it is divided by 3,600, it will be in seconds. So that is equal to 3.07 kilometer per second. So 3.07 kilometer per second will be the velocity of this particular satellite. This is all there in this particular video. So I have solved most of the exercise questions which were there in this particular chapter. So the next chapters which are there in 9th standard science subject after this particular motion chapter, I'll be explaining in my subsequent videos. So if you want to learn more physics, chemistry and mathematics like this, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.